Dear students, now we are going to discuss about analog to digital converters and digital to analog converters, that is interfacing with Arduino. So now that everywhere, whatever the projects, so while we connecting these Arduino boards with some application, we need to interface with that some conversion we need. So that means we can integrate that particular Arduino with ADC and DAC. So simply we called it as ADC and DAC. So now see here we are going to discuss how we can integrate Arduino with ADC and DAC. So the Arduino boards handle analog signal through the two main method. So the first thing is we can integrate analog to digital converters depending on the model. Otherwise, we can do pulse width modulated simulated or true digital to analog converter. The first thing is analog to digital converter. So the analog to digital converter, it translates the voltage from the physical world into number of the microcontroller can process. So that means, for example, suppose I want to record my voice, otherwise I want to sense the environmental temperature, otherwise I want to sense the moisture of the air, otherwise I want to sense the humidity present around us. So whatever the physical data you need to sense, that information is converted as digital, as the microcontroller can read as zeros and ones. So that is the process of analog to digital. So analog means any physical signal in nature. So that signal we need to convert it in the term of digital numbers, that means zeros and ones. So now see here this diagram. So this is the analog Arduino board connected with this analog to digital. So whatever the data we have, so that will be converted as zeros and ones. So now see here we are using that analog pin A0, that we are connected with variable resistor. So whatever the heat or temperature, if you want to measure, that will be measured by the analog sensors, that will be converted as digital form in with Arduino. So then only the microcontroller can read easily. So this is the diagram of Arduino microcontroller. And now see here how they are using this analog to digital conversion. So most Arduinos uses the technique called successive approximation resistor. Simply we call as SAR. So what it will process means, it will sample the voltage and it compare it against the reference to find the digital value. For example, if you are having 4.6, so what is your reference value? They can make 5. So it will be compared with that reference value and it will be compressed and it will be converted as digital value. For example, if you want to read 2-bit pulses, okay, so for that you might know that equal representation for 0 0 0 1 0 1 2. So you might know this binary representation for 0 0 0. So this is the analog value. So this is the digital representation. 1 means we have 0 1. 2 means we have 1 0. 3 means we have 1 1. So like that that values will be approximated. Approximated means, for example, if you are having 0.9, it is approximated as 1. So now it is converted as digital. So now that see here that resolution and accuracy, for that UNO R3 we have 10-bit resolution and we can do the 1024 discrete steps and 5 reference levels. Similarly UNO R4 we have support the 14-bit and it will be support 12-bit. And the sampling rate we are using here is 9600 Hz. And what are the key code we can use for this analog and digital? This is very important in our programming part. We are using this thing only. For initiating value we have analog read of any analog pin numbers you can mention here. See here. So this is the code initiate value, that analog read. This is the keyword key code. So this is any analog pin we can use. So for that purpose we are using this. The next thing is, so this is the real time image of Arduino Uno connected with one analog input. See here that same circuit board we are displaying here. The next part is digital to analog converter. So now whatever the operation done by that analog to digital conversion. So there we what we have done, whatever the analog values, that means physical signals are there, that is converted into digital. So now this digital to analog converter do the reverse process of ADC. That means it reconverting the digital values into analog. Then only we can able to read or able to hear that particular process values. So now see here that it will be reversing the operation based on specific voltage based on the digital number. Okay, for example, if you're having that 4, that means it will be approximated. No, suppose we have 3.9 or 3.9. So based on that, it will be reversing to analog value. So this is the circuit for digital to analog converter. So here we digital to analog converter, we can call it as two name, pulse width modulated or the PWM or the true DAC. Okay. So here also you might see here that whatever the process we done, that everything will be reversing in that side. So that the value will be, the digital values will be converted into analog values. And here, so true DAC available on the newer board like UNO R4. So it is a steady analog voltage, but the PWM is the simulated version. So it we can use for this LED for the filtering of audio, and like that application we can use. So what are the key features of this digital to analog converter? We can generate waveform generation, and we can direct memory access we are using. So what is the key code? It is very important in the project part. So we can use see the analog write. So because you are reconverting back, so now this whatever the pin you are connected DAC and what processor you are connected, that pin numbers you have to specify here. So now the real image of Arduino digital to analog converter. So now see here. So this is the Arduino digital to analog converter. So thank you.